Angie or somebody who got theirs done how they got theirs done, because I've got it set up right, and like 15 people have turned theirs in.
Yeah, usually that puzzle works.
Yeah, I don't know.
Did you have it? Did you do like? Did you have a due date?
Yeah, I put a due date on it.
No. I mean like on the end of the
8/14.
Yeah, the last day of the
Okay. All right. So, okay, so today, what I want to do first off is I want to go over, just real quick, I'm going to go over the multiple choice on the Unit 4 test, because we already went over the free response questions in preparing for the test. I'm not going to spend time going over those. So go ahead and go to Unit 4, the last day of Unit 4, and open up your Unit 4 test, and you ought to be able to look at the you ought to be able to look at your questions, and you ought to be able to see what the correct answers are. So if you have questions about any of those, we will take a few minutes to go over them. It would be the last day of Unit 4, so go to Unit 4 and go all the way down to the very last date. I believe that was 14th maybe, or 13th, or something like that. So, okay. So when you see your score in now, that has been curved. When you see your score when you first open it up, that's been curved. But I think if you open it up, it'll give you your uncurved score as well. So, yeah. And so, very quickly, any questions over those? And let's see. Looks like number 11 caused a bit of problem. Let's see if I can. No, I'm not going over free response because we've already done free response, so I'm not going to go over that. Question number 11 is this one. 2H2O2 plus 4 LMNO4 and 3 ClO2. It's a titration reaction, so that's your balanced equation. How many moles of ClO2 are needed to completely react with 20 milliliters of 0.2 molar KMNO4 solution? All right, so one of the main problems that we forgot or we didn't think about is that capital M means moles per liter, not moles per milliliter. So one of the first things, or one of the big things that people forgot to do is we forgot to change milliliters to liters. Okay, you have to do that conversion. And then you would need to find out the number of moles. So we would take 0.20 moles per liter. 1 liter is 1,000 milliliters. And we had 20 milliliters of solution. So to find our moles, we would take 0.2 divided by 1,000 times 20. And that should give us the correct number of moles. Okay. And then that would be moles of MnO4. We want to know how many moles of ClO2 are needed. So we would then take that and set up a unit multiplier based on the balanced chemical equation. So you would take your answer from this, and you would put it over here. So this is going to be MnO4 moles. And you would go, according to my balanced chemical equation, 4 moles of MnO4 reacts with 3 moles of ClO4. Or ClO2, sorry. And then I can get the correct moles of ClO2. Okay, so any questions on how we got that one? Okay, and that's going to be a big thing for this next chapter, is remembering that capital M means moles per liter. So if they give you milliliters, you've got to change it. And they're going to do that a lot, is they're going to give you one unit in the problem and ask you to find the answer in another unit, like hours, and ask you to find it in seconds or minutes. So you're going to have to do those conversions in order to get full credit. That was one that most people did not get correct. So are there any other ones that you want to go over? Yes, Angie.
On my screen it says number 9, multiple choice. It says, so according to, it's a 2 KClO3 solid makes 2 KCl solid plus 3O2. According to the equation below, how many moles of potassium chlorate?
You said number 9.
Okay. For me, it's number 9.
We'll see. Nope, that's not. Okay, let's go back to. Let's go back to this.
Go to the unit 4 and the last one.
Is that it?
That one, yes.
Okay. So in this one, what you had to set up a unit multiplier as well, but they just do their unit multipliers a little weird. That's all. According to the equation above, how many moles of potassium chlorate must decompose? So potassium chlorate is this one to generate 1 liter of O2. Okay. So 1 liter of a gas, or I'm sorry, let me rephrase that. 1 mole of a gas is 22.4 liters. Always. Okay. So if we look at our equation, we have 1 liter. We're trying to generate 1 liter of O2. And we know that 22.4 liters would be 1 mole. And then of O2. And then we know that 3 moles of O2 are the same thing as 2 moles of KClO3. And I was looking for moles of KClO3. So that's 2/3 times 1 over 22.4.
I think I put the KClO on the bottom. So I had the 3 over 2.
Oh, okay.
I had everything else good. But
Okay.
I just switched the 2.
All right. So most all these, you need to do a unit multiplier. Remember, when you're doing unit multipliers, the unit you want to get has to end up on top. And the unit you're given is going to wind up being on the bottom. And then you just step it from there. And cancel them out until you get to the unit you want. Okay? Any other questions? Okay. All right, so unit 5, we started that the day of the test. You had assignments the day of the test. And I told you before, we have to get finished with this in 3 weeks. So we're about to start week 2 of this, okay? So you need to be keeping up with your assignments in here. And it's going to be one of those things that if you procrastinate, it's going to snowball really fast. Really, 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 really fast. Okay, so make sure that you don't procrastinate on these assignments. Evidently, if your ed puzzles didn't work, go back to Friday, the last day of Unit 4. They were also assigned on that day, so you should be able to watch them in one of those two places. All right, so today we have a POGIL that we're going to do. We're going to talk about this Unit 2 checkpoint. These things will be what you need to do for homework outside of class. Notice they are due the 25th by the time you come in class on the 25th, okay? So please make sure you have those done. I have the 5.3 topic question. I have that graded. I had about 11 people had those turned in, and I have it graded, and I have put comments on there, so you ought to be able to see what you did. Let me urge you again to not Google the answers, okay? I can tell some of y'all Googled the answers. It's really easy to tell.
What?
On the topic question, 5.3 topic question, there was some Googling of answers going on there. It's not up here. Don't look for it. It's not up there. It's not on the screen. Okay. I know, for example, it asks you to estimate the bond angles of a Lewis structure. And some of you got very specific with your number. There was nothing in that problem that would lead you to a specific number that some of y'all were giving, unless you Googled it. Okay? I don't want you Googling it. I don't want to know the bond angle of that just because it's all important to know that angle. No. The point of that question was to see and go back to what we studied back in Unit 3 when we studied molecular geometry. Anytime you have 3 bonding domains and no non-bonding or no lone pairs, it's always trigonal planar, which is always 120 degrees, thereabouts. So people who are putting 117 or 121.3 or something very specific like that, you Googled it. That's the only way to get that specific number, okay? Because there's nothing else you have. Even if you looked it up in a textbook, which you have, which I don't care if you use, it's not going to tell you 117. It's going to say less than 120 at most. It'll say less than 120. Okay? So guys, come on. When you're Googling things like this, you shoot yourself in the foot. Because you're not thinking. Okay? You got a textbook at home. If you don't, you need to see me so you can get one. If you have a textbook at home, if you have questions, go to that textbook. Go to your notes. Go to the ed puzzles that you were supposed to do. Go back to the daily videos. Don't let Googling be your first instinct because it doesn't help you in the end. Okay? So, there's my little soapbox. Yes.
Okay, so, alright, so for the free response question on 5.3, and
Yeah, topic question on 5.3?
And
Yes.
The last part was, okay, so I didn't really, okay, so the last part I could not find in any of the videos that we had watched, and so I was just like, I'm gonna, I didn't know where
Hey,
to go
that's-
to that.
That's okay. That's fine. If you don't know a question, I would prefer you give me something out of your brain and have it be wrong than Google it and have it be right.
Yeah, I was like, I have no
Okay.
clue, I wouldn't have found it.
Because
It was
the
like-
more you use your brain and think about things, the more things are going to begin to piece together for you, and you're going to start getting more of them right.
I was glad to know clue.
So,
when I found it, it was like
The very last one, E is talking about the catalyst. A catalyst is something that does not get used up in a reaction. Okay, some people gave me that definition of catalyst. Great. But that's not exactly what the question asked for on the free response one. Question E says, how do you know that chlorine is not the catalyst? Okay, so it tells you chlorine's not the catalyst. How do you know it's not the catalyst? Well, if a catalyst doesn't get used up in the reaction, that's how you know something's a catalyst. The chlorine got used up. Okay, the chlorine didn't, you don't have, if you look at this set of equations, at the very end here, you don't have chlorine, do you? No, you don't. You started with chlorine over here, but you didn't end up with it. It changed completely. In order for chlorine to be a catalyst, it would have had to be a product on this last equation. But it's not. So that's your answer. It's not a catalyst because it was used up in the reaction.
Can
Yes.
you go over? Okay, if you scroll up. I was more like I looked at more of like the.
Go
Of
ahead.
like the ones that were at the very top, I guess. Not like this way to get that. And so like I had like they like the people on the internet were like the answer is like this equation with like E and K and T, and I'm like, when did we learn this? So
You learned it in your notes when we talked about rates of reaction.
I was like,
Okay, the rate of this reaction, and it's also, like I said, and I mentioned this in the Google Meet. Someone came to the Google Meet, which would be a good idea when you have a question, is to come to the Google Meet on Wednesday. But anyhow, you look it up in your textbook. This unit corresponds with chapter 14 in your textbook. Okay, and in your textbook they talk about, and in those ed puzzles that you had to watch beforehand, we talk about rates and rate laws and how to find the rate law, how to know if something's first order, second order, zero order. Okay, something that is this is going to be a first order reaction. There's a couple of ways to tell. First off, we are plotting concentration versus time, and it is not a straight line. In order for something to be zero order, concentration versus time gives you a straight line. That's not a straight line, is it? So it can't be zero order. Second order, there isn't a graph of concentration versus time that we look at for second order. Okay? Which only leaves us one other option, that's first order. The other way to tell is that if you look at this, it is decreasing, the concentration is decreasing by half for every 8 seconds. So 8 seconds, half of it's gone. 8 more seconds, another half is gone. Okay? So this shows us the half-life, and half-lives are only associated with first order reactions. That was also in the ed puzzles. Okay? So you know that this rate law is first order, and it's first order by either one of those reasons I said, because of the half-life, because every 8 seconds the concentration decreases by half, or you could say because this graph is not a linear graph, so it has to be first order. Did that answer your question? You got it. Watching the 2 ed puzzles first would have helped. Yeah.
I just was like, I have no clue how to do it.
Yeah. So
Google help.
that's why I assign those ed puzzles first. So, yes, ma'am.
Can I ask a question about the checkpoint 1 thing?
Yes, what about it?
Okay, so it used like the terminology rate of formation, and in the rest of them, like it had given us like a set rate and a concentration. Yeah, but it didn't have like, and I had no idea. Maybe it was.
It's the same, yeah, it's just same terminology. It's different terminology. It just means what's the rate of that reaction.
So how do so here's the thing, I work everything out even when they give us the easy ways, because the easy ways are like too complex for my shallow mind. And so like that didn't have like the rate for me to like cross out, do my
Okay,
algebra.
so this one is not, it's the terminology. It's not asking you for a rate law. Okay? So rate law is first order, second order, zero order. This is asking for rate of formation. When it says just rate, they are talking about change in concentration over change in time. That's it. Okay? So in this one, what they want you to base it off of, because they didn't give you a table or anything like that with data, they want you to base it off of the equation. Okay? The balanced chemical equation. And I think it's the first Ed puzzle, they gave you this thing where it says, all right, if you have a product or if you have a reactant A, then the rate for that reactant, the rate for that reactant is just going to be the change in concentration of A over change in time. Okay? So rate for A is the change in concentration for A over change in time. And for B, the rate for B is going to be equal to 1 over 2 times the concentration of B over change in time. Okay? And so on and so on. And they're all equal to each other. Because as this is going down by half the amount. This is also forming, so that would be going up by a proportional amount. And this, well, let's draw up our, and D is forming by a proportional amount. Okay? So the way they express it is they put them all equal to each other, and then you would multiply by 1 over the coefficient. So if there's a coefficient in front, you multiply by 1 over that coefficient. So all they wanted you to do is recognize that. So for D, rate of formation of D is just going to be equal to, C, but if you notice, C is forming 3 times faster, right? Because there's a 3 in front. So the rate of formation for D would be 1/3 times the concentration of C over change in time. Change in concentration over change in time. So you would just take this number and multiply by 1/3. Because that is that, right? Because they told you that. They told you the rate for the formation of C is 9. And rate of C is the change in concentration over change in time. And this thing is forming, C is forming 3 times faster than D, right? Does that make sense? Do we see why I'm saying that? That C forms 3 times faster than D? Okay, it's based on that coefficient. Okay, so to find the rate of D, since C forms 3 times faster, I'm going to divide by 3 or multiply by 1/3. It's all the same thing, right? Does that make sense? So they just took and said 1/3 times 9. They didn't want a rate log. They just wanted the actual rate. And then you would do the same exact thing for the other ones, but you would just be setting it up a little bit differently. So the disappearance of A, it's the same equation. The disappearance of A is just going to be the same thing because this A is going down 1/3 as fast as C is forming. C forms 3 times faster than A goes away. So what would B be? How would I set up the disappearance of B?
It would be 9 molar hours times that by 1/2.
1/2? Close, but not quite. All right, so look at here is B, here is C. 2/1? 2/3? Okay. It is 2/3. It's 2/3. Hmm?
Can I see what
Oh, I don't know. Yes.
You'd be able to see your screen, be able to see.
Or what?
I wanted to see the board in front of me, but I thought it would be. Should we be able to see your screen?
We should be, but I probably didn't present yet because when I first came in here, nobody was here. So I will present now. Thank you. All right. So does that make sense on that one? There's a little more memorization of formulas in this chapter than we've had before. And if you can remember the formulas, it'll make things a little bit easier. Like there is a formula that all of these are equal. The rate of 1 over A times the concentration A over concentration over time equals 1 over B, where the A's and B's are your coefficients. Okay? So if we just did that, this is what the rate would look like. And again, it's not rate law, okay? It's just the rate. It's going to be 1 over 1 times the concentration of A over change in time. Change in concentration of A over change in time. And that's going to equal 1 over 2 times the change in concentration of B over change in time, which is going to equal 1 over 3 times the concentration of C over change in time, which is 1 over 1 times the concentration of D times the change in time. Okay? That's just kind of the format of how you do it. You put the coefficient in the denominator, that's 1 over that coefficient times whatever the concentration is divided by the time. And in this case, they give you what the rate is. They just want you to know that you got what you have to multiply that number by. All right. All right, so you have a POGIL for initial rates. So let's go ahead and open that up. And download that. All right, so in most cases, the rate law for a chemical reaction cannot be derived theoretically. If the reaction is a multi-step reaction, the rate law does not correspond to the balanced chemical equation. Finding the rate law would be simple if we could observe the reaction on a molecular level, but obviously we can't do that. So we have to use indirect evidence. There are many experimental techniques that can be used to determine the rate law of a reaction. Determining the initial rate of a reaction and seeing how the initial rate changes when the concentration of reactants are changed is one way of using experimental data to determine the rate law. Okay, so what we're going to do is we're just going to go through this. And in the end, this is going to help us be able to understand and determine rate laws for a particular experiment. Okay, so I'm not going to, we'll go through a few of them together, and then you're going to walk through it on your own, and I'll be walking around. Okay, so the effects of exponents. So if we have y equals kx to the nth power, where k is 5. So what they want you to do, we're just starting with the simple math, because this is what this is based on, math. Okay? So we're just looking at how does an exponent affect an equation. So you'll need your calculator, you may need a piece of paper, scratch paper, and pencil. So let's get that out. So all you're going to do pretty much is plug and chug. That's pretty simple algebra there. We're just plugging and chugging, okay? So make sure you have your calculator, something to write with, some paper. All right, so if n equals 0, then y would equal what? So our original equation, now for me, and having been a former math teacher and having been a former math teacher who used to not like math when I was in college, the best way to get over that and to make sure that you know what you're doing is don't try and do it all in your head. Write it down. Write it out and work it out. When you do that, you see the patterns, and then it makes it better, makes it easier for you. So get out a piece of paper. Or you're not going to have enough room on here to show all your work. So for each time, I'm going to erase it every time, but you can't do that. So if k is 5, x is 1, and n is 0, what is y going to be? Hmm? 1. Why?
Because anything to the 0 power is
Yes. Anything to the 0 power is 1.
the degrees.
No, 0. 0. 0. So your answer, like I said, I plugged that into this equation. That's all I did. Okay. So your answer is 1. All right. Staying on that same row. What if we change the 0 to a 1? What happens when I change the 0 to a 1? What is it going to be equal to? 5. 5 times 1 is 5. Anything raised to the 1 power is that thing. Okay? So 5 raised to the 1 power is 5. All right? Now, what if I raise it to the 2nd power? Hmm? 5 times 1 is 5. Whoa, wait a minute. Hang on. What is it going to be? Why? You got to do the exponent first. Please excuse my dear Aunt Sally. Exponent first. So 1 squared is 1. What is 1 times 5? 5. Okay. Why? Pay attention. Okay, remember, that exponent only goes with what it's right beside. Unless I put brackets around the 5 and the 1, you don't multiply the 5 times 1 first. Yes, ma'am.
So why if it's not in brackets, why would the first answer be 1?
Oh. Okay. All right, let's go back and look at that then. 5 times 1 to the 0 power. All right, so what is 1 to the 0 power? 1. You're right. Caught that. Still 5. Okay. All right. So let's look at the next one. Actually, y'all get to look at the next one. I will come back in about 2 minutes and give you, and we'll talk about the answers. So, make use of your calculator. I have to use calculator. Oh, what gets you depended on? Because on the AP exam, the multiple choice part, don't use a calculator. So, don't become so dependent that you can't do without it. Let's stick with the table before we move ahead to anything else. So I do not want you moving ahead. I want you to stay right here at this table. If you are finished, help someone who's not.
Like this one's.
All right, for the second one, when x equals 2, you should have gotten 5, 10, and 20. 5 times 2 to the 0 power, anything to the 0 power is 1, so that would be 5 times 1. 2 to the first power is just 2, that would be 5 times 2 is 10. 2 to the second power is 4, 5 times 4 is 20. Okay, all right. Move on to the third one. So on the third one, yes, ma'am. Way over there. There are some along this wall.
I was like,
Or you can plug it in up here at this table. Here's one. There's 2 plug-ins in that table. All right. So for number 3, what would go in the first blank there? When n is 0, what effect does it have? What's your answer going to be? Y is going to be equal to 5. For the second one, when n equals 1, y is going to be equal to 15. For the third one, when n equals 2, y would be equal to 45. Okay? All right? For the fourth one, what's it going to be? 5. You should see a pattern here. And the next one would be 20. And 5 times, let's see, 4 squared is 16. So that's going to be 30, carry 3, 80. Okay? All right. So we have the table filled in. Consider the mathematical equation. What letter represents a constant in the equation? So which letter is the constant? K. In science, most of the time, our constants are K. In this chapter, they are K. All right, what is the value of that constant? 5. What letter represents the exponent? N. Does x in the equation represent the independent variable or the dependent variable or a constant? Okay, let's go back and think. So is x if you look at that table now, is x the independent variable, the dependent variable, or the constant? Not the constant, right. So we cross that one out. Which one is it?
Independent.
Why did you say independent? Because you didn't change it. You didn't come up with it. It's already there, right? You set x to be 1, 2, 3, and 4. So x is our independent variable. The things in lab that we choose, those are our independent variables. Okay? I set x equal to 1, 2, 3, and 4. That makes it independent. So fill in the table. We already did that. Refer to Model 1. Use complete sentences to describe the change in y as x increases when n equals 0. So that's looking at this column right here. That first column. What happens to y when n equals 0?
nothing.
So we would say what kind of effect does the x have on the y when n equals 0?
No effect.
No effect. Okay, now, you can't, it says complete sentences, so one, you need to put that in a complete sentence. Okay? I'm not going to write it for you, but yeah. So that's question number, we already did 2, that's question number 3. Refer to the column in Model 1 where in the Model 1 table where n equals 1. When x doubles, what happens to y? When x triples, what happens to y? So now we're looking at, let me use a different color. Whoops, nope. So now we're looking here. The second column. What happens to the y when x gets doubled? What happens to y when x gets doubled?
Increases by 5.
When you go from 1 to 2, that's doubling, right? So what happened to y? It doubled. Yeah, it doubled. When we went from 2 to 4, 2 to 4 is doubling, correct? So when we went to from 2 to 4, what happened to y? It doubled. Okay, so there's your answer. Write that in a complete sentence. And then, when we double x, we double y. Okay? What happens when we triple x? So when we triple x, when we go from 1 to 3, what happens to y? It triples. Exactly. Whatever happens to x happens to y. The exact same thing. Now, they're not the same numbers. Okay? They're the same proportion. So whatever happens to x, if x triples, y triples. If x doubles, y doubles. If x were to quadruple, what happened to y? It quadrupled. Okay? That wasn't a question, but. All right, so now you can fill in number 4. I'll give you a minute. In complete sentences, tell me what happens when x doubles, what happens to y? When x triples, what happens to y? Number 5 says use a complete sentence to describe the change in y as x increases when n equals 1. Justify the pattern you see using your knowledge of mathematics. So tell me, based on question number 4, tell me in a complete sentence how y changes as x changes. And it'd be nice if you threw in this one mathematical term that would help. So you don't have to say doubles and triples and quadruples. You could say, as x increases, y is. Somebody started to say it. I heard the beginning of the word, or one of the words. Close. Yeah. It's a ratio. It's a constant ratio or a direct. Starts with P. Proportion. It's a direct proportion. They're directly related to each other. When we use that term direct proportion, it means as one goes up, the other goes up by the same amount. Okay? So it's a little more specific to say direct proportion than just to say they're proportional. Okay? Or just to say as one goes up, the other goes up. because maybe the other one doesn't go up by as much. But in this case, that's not true. When one goes up, the other goes up by the same amount. It's a direct proportion. They're directly related. All right. Third column. So now let's look at this third column. So in this third column, when y, I believe it's asking when x triples, what happens to y? So when x triples, so when we go from 1 to 3, what happens to the y's? Quadruple?
Squared.
Not quadruple. It's not just squared either. Yes, the correct mathematical term would be exponential. It changes exponentially. So by that I mean you go from 1 to 3, you tripled it. That's 3, right? Well, you don't just triple this, you triple it squared. Okay? So you're kind of all around it. But so we say that to phrase that mathematically is we say it rises exponentially because it doesn't rise just equally. It's that increased squared. Okay.
From 5, it's 15, right?
Okay. Think about what number would you multiply 5 by to get 45? 9, right? And to go from 1 to 3, that's tripling it. That's 3, right? Right?
Yeah.
Yeah. And what's 3 squared? 9.
Where's the 45?
Right here.
Oh, okay.
Right there.
Oh, I'm looking at the wrong one. I'm
Yeah.
sorry.
Yeah. Okay. No, you're fine. That make sense?
Yes.
So we increased this by 3. This increased by 3 squared. 5 times 9 is 45. Okay. All right. Moving on to the next question. So that was number 7. And again, justify the pattern you see using your knowledge of mathematics. So use terms like exponentially. That's what we call it. Okay. Consider the data table below and determine the value of the exponent q. Justify your answer with an explanation or a mathematical equation. All right, so here's the equation. Here's the setup. R equals st raised to the q power. And s is a constant. Okay? So we could set it to be whatever we want. It's a constant. Okay? So t is 5. R is 15. Well, if we say S is 1, because that just makes things easier, what would Q be? So if we went 15 equals 1 times 5 to the Q power, what does Q wind up being? 15 equals 5 to the Q power. Was that? No? So what is Q? So basically what you've got to figure out is what is Q. If you know, I had that. Did I have that set backwards? I had that set backwards, I think.
S is 3. Couldn't Q be 1 then?
It doesn't tell us what S is.
You can make a prediction on that.
Yeah, that's what you're supposed to do. You're supposed to use the table. So using the table,
If you multiply by constant, that's like 3.
Yeah. If that's equals 3, then Q will always be 1.
who says Q always has to be the same number? Who says Q is the constant? Q is not the
No, I'm
constant.
saying S is a constant.
Okay.
But I'm just thinking.
I mean, you can set that if you want to. Q's not going to change. I mean, Q is going to change. Q should change. We don't want Q being the same number every time. I don't think. Consider the data below and determine the value of the exponent Q. Oh, no, I'm sorry. I read that wrong. Justify your answer with an explanation of it. So, what's Q? That's what you guys are doing. It looks like it is going to be the same number every time, because it just says determine the value. So if T is 5 and R is 15, what does Q have to be? Okay, and then if R is 30 and T is 10, what does Q have to be?
Yeah, we make S 3.
It says justify your answer with an explanation or mathematical equation. So then write that down.
What is it supposed to be? What is it supposed to be?
I don't have a key right now, so I don't know. That's the beauty of justify your answer. If you can tell me mathematically why your answer is correct, then it doesn't say anything else. Okay, so based on what you got on number 8, answer number 9. So what'd you get for number 9? Are we still working on 8? Okay, give you a little hint of what you could do. Look at what happens to, look at what happens if you take T and double it, what happens to R? And then use that to help you. So if I looked at T, if I compare, so each one of these has this equation, okay? And S is a constant. So if I'm comparing those two equations and S is a constant, then it's going to cancel out, right? Because it's going to be the same for both. So if I compare the two T's, hang on a minute. So if I compare If I compare 15 to 30, and I compare 5 to 10, how do those numbers compare to each other? Hey. Very over the survey. So it should be image and then okay. All right, thank you. Last 5 minutes, you'll have to go in your Gmail and take a survey. Not right now. Take a survey.
They're both 1/2.
They're both 1/2. Exactly. They're both 1/2. Okay? So if they are both half, yeah, 2. What they did is they just compared them to each other and they said, all right, 5/10, that's our time, is going to equal to R 15/30 raised to the Q power. This is 1/2, and 15/30 raised to the Q power is also 1/2. So what's anything, if the two things are the same, what does the exponent have to be? 1. Exactly. And all they did with this is they're just comparing these two equations. These are the same. This equation goes for each one of these. So they're just making a proportion out of them and kind of canceling out the S so they don't have to consider the S. Okay? So Q is going to be 1, which y'all figured that out on your own. So if Q is 1, what is S? 3. Exactly. And again, I'm not going to put it up here. Y'all are going to need to give me a mathematical explanation for why that works. Okay, so you're just going to need to work that out. You can't just put Q as 1 and S as 3. Okay? All right. Consider the data below and determine the value of the exponent Q. Justify your answer with an explanation. Same basic problem again. We just switch things around a little bit. They okay. They are now. If you notice in this data table, the R is the same all the way down, right? So what they're doing is they're not putting R on top and T on bottom or anything like that. They're putting comparing the first set of data with the second set of data. Do you see that? So they're comparing 10 to 20 and 3 to 3. The first set of data with the second set of data. Okay? So, like I said, y'all did this before, so it's up there. You just got to find a way to get it out of here and onto your paper. Okay? So, if we double T, what happens to R? Stay the same. So, if we double T and R stays the same, what do you think Q is? I'm asking a rhetorical question. Meaning, you don't have to answer me. I'm just getting your wheels turning. Okay? So, you bear all that in mind, and you come up with what you think Q is, and a mathematical explanation to justify what you think Q is. Okay?
Does S have an mean value from 9 to 10? Or does it stay the same?
You don't need S, so I'm going to assume yes, it has a new value, because in their explanation, they do not include the S at all. Here's kind of the way I would approach that, as far as, because I think some of you like to have it all nice and worked out. What I would do is say, all right, R equals S, T, Q. That's for this first set of data. And then I'm going to compare that to the second set of data using the same equation. But my s's are constant. So they fall out of the whole situation. They're not even there, right? So 3 over 3 equals 10 over 20 to the q power. Does that make sense? What's 3 over 3? 1. Something raised to q power equaling 1. That means q has to be what?
0. That's all.
Yeah. So that's what they're doing. They're comparing the set of data, they're comparing the two equations to each other. Your S cancels out, so you don't even consider that, and then you just plug in everything else.
So you're kind of figuring out right way.
That's what we're working towards, yes. Exactly. All right. So in this one, Q then has to equal 0. All right, so consider the data below, same thing. Okay, so struggled a little bit on the first one, we kind of got it on the second one. Now let's do it on the third one. Same kind of thing, same problem. Find out what Q is using that new set of data. So what do you think? How would we, let's set it up. How would we set it up?
I don't know if you're supposed to keep the S.
The S cancels out, so you don't need it.
Okay,
We
so
can
that
just-
would be 2 or
Okay.
Q.
Okay, so 12 over 48, that reduces down to what, 1 over 4? And this reduces to 1/2 to the q power. So you got 1/2 to the q power equals 1/4. What does q have to be? 1/2 to the what power? Second power. 1/2 squared is 1/4, right? Which is 1/2 times 1/2, which is 1/4. So that would show us then that q has to be equal to 2. Yes, sir.
You said 48 before on top. That's the first one over 2.
I don't know that I would do that. If you did do that, you have to make sure you did exactly the same thing on the other side, which I think you were. And so, but to me, it would be much easier just to set the two equations over each other and then cancel out your S and then work with what's left. Then you kind of wouldn't, it takes more of the guesswork out of it.
It's just, like, on that percent, right?
Uh-huh.
Like in the videos, they said the hard one on top.
Okay.
There.
Okay. You're right. They did.
It's
So,
just, you don't have to work with fractions.
right. So yeah, if you flipped both of these and said 48 over 12 and 4 over 2, yes, that would be okay. You can do that. Yes, Owen. Okay, so let's move on to number 12. Solve for the S constant in equation 11 above. So now that we know that Q equals 2, we're going to solve for S. So R equals STQ. I'm just going to pick a set of data. It doesn't really matter. So 12 equals S 2 to the squared to the second power. Yeah.
One's named Castleberry. Checking out one lady.
So what would we get for S? 3 again. Yep.
They want to know why you weren't answering your phone.
Yeah, that's the reason. I don't have a phone.
I think we have an answer.
Yeah. Leona, make sure you work on finishing this and the other assignments for today. Okay. All right. Okay, so model 2. So that's building up to rate laws. We talked about a zero order. We talked about a first order. We talked about a second order. Q equals 0, Q equals 1, Q equals 2. All right, so here's our equation. R equals K times the concentration of dye raised to the n power. K is 3.4 times 10 to the third power. So n equals 0. Tell me what the rate is. So for that first one, if n equals 0, what's the rate going to be?
What do we have to write in exponents like that, or can I just say 3,400?
I would get used to writing in exponential form because most of these are done in scientific notation because they're usually really small. So what would it be? 3.14 or 3.4 times 10 to the third. And that is going to be, well, okay. So what if n is 1? How am I going to figure that one out? N is 1. Times 10 to the second? Yes. Yeah. So this raised to the first power is just that. So we would multiply 3.4 times 10 to the third times 0.1, which I'm going to do this without a calculator because y'all got to get used to doing it without a calculator. So I'm just going to multiply 3.4 times 0.1, which gives me 0.34 times 10 to the third power, and then I have to move that back 1. So that's why it's times 10 to the second power. So I had to put it back in scientific notation. It is a 3. Fix that. All right, so now this one I'm going to need my calculator for. No lie. What about if n equals 2? What'd you get?
Did you say constant first? Like, how do you do that?
3.4 times 10 to the first power, yeah. Or just 34. Okay? All right, now, do the next two rows on your own. I'm going to work them up here, and then I'll show you the answer. Alrighty, here's what I got. So on the first column, she stayed the same all the way down. 3.4 times 10 to the third. On the second column, it should double. Well, no, the first two should double. So 3.4 times 10 to the second power, double that, you get 6.8 times 10 to the second power. This one is not going to quite double because you haven't doubled the previous concentration. So it's just going to be 0.2 or wait a minute. Did I multiply that by the wrong number? I think I made it 0.3 times 3.4 e to the third power. Yeah, that's right. 1.02 times 10 to the third power. On the last one, if we double the concentration, we should quadruple the rate. Okay, so 3.4 times 10 to the first power, 1.36 times 10 to the second power. That's 3.4 times 4. And then triple it when you go down to the next column. Yes, ma'am.
Okay, am I supposed to be figuring this out in the other way of just typing it in my calculator? Like, am I
No.
supposed to not know it in my brain yet?
No. No, you're just plugging in. You're plugging in these numbers into this equation up here. That's how you do it.
So like lead to knowing how to do it in your brain, but I didn't know how to do that.
Well, with these, the part that you've got to know how to do in your brain is that when you raise something to the zero power, it has no effect. So that should be the same. The next column, it should double. When you double the concentration, double the rate. When you triple the concentration, you triple the rate. And then for the last one where you're doing it it should go up exponentially. As far as what's in your brain, that's all you should know. You shouldn't be coming up with these numbers just randomly out of your brain.
Okay, and so exponentially, I know like it's the same. So it's like the 3 is equal to 3 to the second power, right?
Yes, that's exponentially. Can we press it? I have a thing on every table, so. All right, identify the reactant in the process being studied in Model 2. So what is our reactant? The dye, exactly. So number 13 would be the dye. Number 14, refer to Model 2. Circle the rate law for the decolorization of the dye. What would the rate law be? And then B, the variable represents, what variable represents the constant? C, what variable represents the order? So, yes, you may ask a question.
What is the rate law?
It's a thing that determines the rate of the reaction. It's what we've been working on this whole time. Okay, so which thing represents the rate law? Which thing represents the order? And which thing represents the constant? So looking back up at Model 2, which thing is the rate law? Which thing is the order? And which thing is the constant? What do you think?
The rate law?
Yeah, which thing is the rate law?
This rate law is it where rate equals K?
Yep.
You have the outside.
Yep.
Dye.
The whole thing. Yep. What I have circled right there, that is the rate law. A rate law is an equation that says rate equals, and then it gives a constant and a concentration, and an exponent. All right, so that's our rate law. So what variable represents the constant for that rate law? K. What variable represents the order for the rate law? N. And in here, you're only going to have 3 orders: 0, 1, and 2. That's it. That's what you have to choose from: 0, 1, and 2. So fill in the table in Model 2. We did that already. So the unit should be molarity per second. So all of these should be capital M per S. Capital M per S. Capital M per S. Get used to your units, because if you watched the Ed puzzles, she said very specifically, they will ask you questions like, what are the units for K? So you got to get it right. There's no partial credit on that. You got to get it right. So if you're carrying your units through your calculations, finding the unit is not a hard thing. If you leave it off, then it is. Okay, 16. How does the initial rate of the reaction change as the concentration of the reactants increases when the order of the reaction is 0? So for that first column, how did the rate change? It didn't. Okay, no change. Changing the concentration had no effect. Let's keep it in complete sentences. So changing the concentration had no effect. How does the initial rate change as the concentration of the reactant increases? When the order of the reaction is 2. Yeah, I thought it was going to be double 2, but they're saying, look at the last column. Okay, so if you increase the concentration, what happens to the rate when it's second order? Exponentially. It increases exponentially. Or quadruples. It actually quadruples.
17.
Oh, that's 18. Did we skip 17? Oh, okay. I'm sorry. I was looking at 18. Sorry. So 18 quadruples. So then what happens to 17? Sorry. Skip one. What happens when the order is 1? What happens to the rate when the reaction is first order reaction? It doubles. Yeah. So 17 doubles. So this would be, and again, you need to put it in complete sentences. Don't just copy that. 17 doubles and 18 quadruples. Okay. So now we're getting into some actual data for an actual equation, not just made up stuff, okay? It's the same stuff we've been building on, okay? So here is our rate law. Rate equals K times the concentration of ozone to the nth power. You have two concentrations, and we look at their rates. Determine the order of the reaction with respect to ozone and justify your answer. All right, so really all you have to do is look at what's happening to the concentration of ozone. It doubled. What happened to the rate? It doubles. If they both double, what's the order? 1. So N equals 1. So it's first order. N equals 1. And you need to explain why that is. Now, if you want it says give an explanation or a mathematical equation. If you wanted to give it in terms of a mathematical equation, you would set it up just like we did those other ones. You would say 0.44 over 0.88 equals 0.01848 over 0.03696 raised to the n power. That's 1 over 2. This is 1 over 2. So n equals 1. Okay? Yes.
So, like in the ed puzzles and all that jazz, when it says with respect to, does that mean in your rate law it's attached to that one?
It's attached to that particular reactant.
Okay,
Because
so
each reactant, in the overall equation, each reactant is going to be a little bit differently. Some of them are going to go faster than others if they have that coefficient in front. So when we say a rate law, we always say rate with respect to, and we name that particular reactant.
okay, so if there was another one there, you would just know that
You would
that
have,
order
you have
is
to do the
specific
same
to that.
thing. You have to do the same thing for the other reactant.
Yes.
And that's how we get our overall rate law, or overall order of the whole equation. We do it for each reactant. That's probably coming later. But, yeah. Any questions on A? Put the hand sanitizer down.
It didn't smell like anything.
It stinks. It's okay. Put it down. Unless you have to wash your hands with it. All right, B. Use one set of data from the table to calculate the value and unit of K. Hint. What unit must K have in order for the rate to have a unit of atmospheres per minute? So now we have to use what we know and solve for K. So we know rate is equal to K times the concentration of ozone to the first power. So we're just going to pick some data and solve for K. This is just plug and chug. Algebra. That's it. All right, so if I take the first one, so, huh? Oh, I can. Yeah, I can go ahead and solve for K first. It's however you like to do your algebra. It doesn't matter, really. I like to put numbers in first and then solve, but you do it however you want. It's fine with me.
That was just how I saw it.
Yeah, on the ed puzzles, I think they probably did rearrange it first and then put the numbers in. But like I said, you're going to come to the same end either way. So, all right. So 0.44 and 0.08, so 0.01848 atmospheres per minute equals K times 0.44 atmospheres. Okay, and anything raised to the first power is that thing, so all I'm going to do is divide both sides by 0.44 atmospheres. Atmospheres will cancel with atmospheres, so I will be left with minutes to the minus 1. Is that right? Yeah. Minutes to the minus 1. So 0.01848 divided by 0.44. 0.42 per minute. Or you can say minutes to the minus 1. It's all the same thing. Okay?
So minutes minus 1 will be the same thing as.
It's the same thing as per minutes. The minus 1 just means it's in the denominator. If you were to write it as a fraction, it means it's in the denominator. That's all it means. So you can write it however you want. Yeah. In AP, most of the time they'll write it as minus 1 just because it's easier to write it that way, rather than putting the slash and all that. It's a little easier to visualize.
So K is per minute.
K is per minute. The other way they're going to write it is 0.42 minutes to the minus 1.
Okay, so you're 8. Okay, so.
So you have an atmosphere in the numerator and an atmosphere in the denominator, so they cancel out. That leaves this atmosphere is in the denominator. So it stays in the denominator, it stays in the bottom, which is to the minus 1 power, or per minute. Yes?
So why is it 1.42?
Unless I divided wrong, which is entirely possible.
Not 1.0.
Oh, yeah, it is 0.042. I just put my decimal in the wrong place. Sorry. There we go. Sorry about that. Okay. All right. So we got 20, we got 21. All right. So we are not going to finish this whole thing today. You will need to continue working through it to get to the whole thing. Okay. This is going to take you through rate laws, determining rate laws, everything that you've done in these ed puzzles up to this point. It's going to walk you through those. And then at this extension, we might actually get to the ed puzzle for Mondays, which is instantaneous rate. Okay. So that may come on that extension question, and you'll be using the graph for that.
So we did the whole package.
Yeah, you gotta do the whole packet. You do the whole packet.
Do?
Whenever I don't know what did the due date say? Monday. I think it says Monday. Do not procrastinate, because you got a lot to do. If you procrastinate and wait, like some people have till Wednesday night at 10:30, I can guarantee you something is going to go wrong and it's not going to get done. So please do not procrastinate. Yes. Checkpoint 2.
That's what it's due tonight.
Checkpoint 2 is, it does say it's due tonight. And so what you're going to do with checkpoint 2 is, you're just going to work out, answer questions A and B, which is the same stuff we've done today in class. Okay? It is finding a rate law based on this information, and then finding out the initial rate of disappearance. Right? It's not on the table. It may anybody think, initial rate. Right here it is. Oh, here it is. No, that's not it. Okay? You have to determine it. We're looking for the rate that this disappears. That the oscillate disappears. Yes. No, it does work. What you have to do is you have to completely sign out of your Chromebook and go to the sign-in page and go to apps and click the lockdown browser app, but click the one that only says lockdown browser. Not, and there's two of them. There's one for Scantron, and then there's one that we're gonna use.
Yeah, I couldn't figure it out, but
Well, you gotta do it before we have another quiz.
well, yeah, I know, but like the Unified Checkpoint 1 is timed out before I do 2.
Oh, it timed out? Oh.
Like it wouldn't let me, like,
No, it's not gonna let you again.
no, I haven't attempted it at all. But it wouldn't let me.
I don't know that, I will see if that ties to the lockdown browser, but either way, if it is, you need to go through and do your lockdown. Yeah, you need to set up your lockdown. Okay? Alright, so y'all need to go in, don't pack up, y'all need to go in and take that survey. Go in your phone book, look at your email, and take that survey. From something to education, fan of Rama or something.
I already did the survey.
No, they released it like a while back.
Well, do it again, just because you told me, and that way I can say, yeah, you did it. If they say, did you tell them to do it?
Yes.
Okay, I have a question.
Yes, ma'am.
So in that ed puzzle thing, the chick like laid out the rates and then they did, is that okay? It's a little bit different than what we did in class.
Did they do the panoramic,
Like,
survey?
Yeah, do it, if you want to do it like she did it in that puzzle, yes. That's
you know what
fine.
I'm talking about? They just put them on top of each other, experiment 1 and experiment 2,
Yes.
did the rates, and like that made more
Yes.
sense.
That is what, yes. And that's what we've been doing all along. Because like when we went back over here, we were putting them on top of each other. We just didn't have a big long thing. So like right here. That's what we did. We just put them on top of each other. And then cancel out the K's and top. So yes, that's fine. You can do it that
I'm
way.
sorry, I think it's just because that's what I did the first time, so like that's what I keep trying
Yeah.
to compare.
Oh yeah, yeah. And this, they gave you the data table, so you are definitely going to do that. You're gonna look at, like you'll look at these first two that are constant, and you'll find out what happens to the oxalate and the concentration here. Then you'll look at these two because the oxalate is constant, so you'll compare these two and see what happens. Yeah, and do it just like she did it. That's fine. I will reset the Unit 1 checkpoint so that y'all can take it again because a lot of people didn't realize it was timed. So I'll allow you to do this twice.
Well, I saw 7 minutes and I didn't know what I was doing, and so my answers are like,
Yeah, which is, I knew they were going to be, so. But I'll reset it again. But let me do that before I forget. Oh, no. Yes.
I was wondering if you could explain this.
Okay.
It's on the 5.3 topic questions. I've done all of them
Okay.
except for D.
All right, so on D, you're going to write a rate law consistent with the mechanism. So on these, the only step that matters is the slow step. So that's what you're going to look for. That's what you base your rate law off of, right? Okay, so there's only one thing in here. That's the CL2. So your rate law is going to be rate equals some constant K times the concentration of CL2.
With no exponent.
With no exponent because there's no exponent. There's no coefficient in front of the CL2.
Okay, I
So
just didn't
just
know what
that.
to do with all of this.
Yes. These you don't do anything with.
Okay.
You
Why
guys,
do
so you
want me
just
to use the
learn
slow one?
because since we're talking about rate, how fast something happens, this is the one that's going to matter because it's the slowest one, right? You know, you're only as strong as your weakest link kind of thing, or you're only as fast as your slowest person.
Okay.
That's the same kind of thing. Okay, so you only look at the slow step. You don't have to look at the rest of them. Now, to answer the catalyst question, you'll need to look at all three.
Okay.
Okay, does that make sense?
Yes, ma'am.
Okay,
Thank you.
you're welcome.
I